Yeah. Just give people a beer and everything is fine, right? Okay, so my name is Filip. Filip Rakowski. I live here in Wrocław. I'm a CTO and co-founder of Vue Storefront. Now, how many of you know about Vue Storefront, know what it is, or heard about this? Please raise your hand. Nice. I mean, it could be a little bit biased because it's our city, but it's still great. So yeah, today the title of my talk is everything you need to know about web performance. And if you don't tolerate very well harsh content, a caution, there will be a lot of Comic Sans here, because that was the only font that was fitting into my images. So just letting you know. So for those who didn't raise their hands or haven't seen that because you're online, just a quick info of like what Vue Storefront is, because this is actually an interesting story, because we started as an open source project 4 years ago, built here in Wrocław, and soon we became so popular that we decided, okay, like accidentally we kind of like created a market standard, so maybe let's create a company and see what happens. So this is exactly what we did. We started 1.5 years ago. It was 6 of us. Now there's 100 of us, and we are growing every month with 10 or 20 people. We will see if this is leading to catastrophe or a huge success. But basically what Vue Storefront is doing is, this is just a front end, and we all know what is front end, right? For the e-commerce, and whatever you will plug in, like any e-commerce platform, any CMS, this is already there. And if you ever try to build a front end for e-commerce, you know how hard it is. Like, it's very easy to get the data and show the proof of concept, but from there to production, your life is gonna be tough. And we are basically giving you a ready-to-use front end with UI library, everything. And one of the key selling points of Vue Storefront is performance. And you know, people keep saying that performance is hard. Like, do you think performance is hard? Raise your hand if you do. Okay, like half of the people raised the hand. I will tell you this. I don't think it's hard. And I think it's easy to say it's hard and just, you know, move on to do other things. It's easy to admit that. Everyone admits that, and everyone are happy. But the reality is that it is not hard. I would say it is more like overwhelming, because there's a lot of terminology, there's a lot of tooling, and when you just want to make your website fast and you're starting to read, like, okay, so what I should do? And then you're reading like Core Web Vitals, Lighthouse, Field Data, Lab Data, Google PageRank, like bunch of stuff that you have no idea about. And then you need to dig, like understand what each of those things means. It could feel very overwhelming, but in reality, it is not that hard. I mean, it's hard to be expert in web performance, but it's not that hard to build a fast website. It's actually a knowledge that you can get in like 20 minutes, maybe 30, and I will try to prove that. You will tell me in the end if I did. And what I believe in is that it's all about a good mental model, because if you're starting from the bottom or from the middle and you don't have this helicopter view on the whole issue, yeah, it could feel a little bit overwhelming, but you know, we are programmers, we all know this rule, divide and conquer. So if you can't solve any problem on its own, just divide it into smaller problems and solve them on their own. So with web performance, it's all about a good mental model, and here is my proposal. So if we break down the web performance, these are actually the things that are influencing the speed of your website. There's nothing else. There is some work that has to be done on the server, then there's a network part where this data is being sent to the client, and then there's a client part. That's it. End of talk. Of course, that was a joke. Very funny one. So I will focus only on the most important things here, because obviously, like, you know, it could be like a full day workshop, and I would love to give one actually, but we don't have that much time. So I will try to sell you this idea. Like, it's very easy to have a good performance, and there's not that much you have to know about this. So let's start with the first piece, which is the server. So what we define as a server work. Basically, this is just a code that runs on a server, And once the execution is finished, then we are sending this to the client. And the time before it's being sent to the client, we are calling a server work. And the metric that is describing this is actually, I think, the only metrics that I'm mentioning on the stock. It's called time to first byte. And like majority of the time to first byte is basically the server execution time. And this is a very important metric because usually like the time to first byte is the time before which your user doesn't see anything, like a blank screen. So it's very important to optimize this metric. And a good score for time to first byte is around 200 milliseconds. So it's like a blink of an eye. Blink of an eye takes like between 100 to 400 milliseconds. And everything like that is around 100 milliseconds is also perceived as something instant. So we're not giving our users a chance to do a mental context switch to think about, some news that are happening or thinking about, a cat websites or anything. We're immediately displaying something to them. And if you want to actually see the time to first byte of your website, just open the network tab, take a look at the first request. This is usually an indexed HTML, and just click on it and see what was the time to first byte. And this is the time that actually was spent on the server to generate the HTML, and then it is being sent to the browser. And as you can see here, in this particular example, like the file was probably very small, it was sent very fast, but it took 15 seconds on the server actually to get it. Like, would you wait 15 seconds on the website? I don't think so. Especially now when, an attention span for all of us is probably like 3 or 4 seconds. And then we are switching. Oh, I forgot about one thing. So, like, what are the biggest contributors to the server work? Well, when we are building a single-page applications, we are basically running the same code, the front end and on the back end. So, code execution time, of course, and API calls. And API calls, I would call them the biggest factor. Like, if you have a lot of API calls on the server side to external domains, it will take a lot to actually build the HTML, and the time to first byte will be very long. So we'll try to avoid this. Now, what are actually the best ways to optimize time to first byte? Well, the best code, or like the fastest code, is the one that never has to run, right? So ideally, we should cache the result of the server execution and just send the ready one to the user. So time to first byte then it equals almost 0. Of course, it's never 0 because not only the server execution is included into this time to first byte, but majority of it is. So prefer SSG over SSR if this is possible for you, and trust me, it is almost always possible. Like if you find yourself needing SSR instead of SSG, probably you're overcomplicating. I'm not saying that it's in all cases, but in most cases it is like this. And if you can't really use SSG, then just really use CDNs and cache everything, because essentially it will be almost like an SSG. Another thing is what I said already, so optimize third-party calls. There is a rule that you should fetch fast data on the server to get the fastest time to first byte, and then slow data on the client. So basically, we are creating this HTML as soon as possible, sending to the client, and on the client we're fetching other things that maybe are not that much important right now, but generally, like we want them. Of course, if there's a heavy caching being utilized and you're like cache warming, which means that you're entering all the websites, so the replica is being put in the cache, maybe you don't have to follow this rule, but in general, as a rule of thumb, do this. And this is something that I already said, like when we are having a universal applications, which means that we are having a server-side execution, then we are coming to the front end, and on the front end we are having client-side execution called hydration. It's actually the same code, so just optimize it and it will be fast. Are you following? Cool. Okay, so the second part is network, and we can't do much about network actually as a front-end developers, but there are some things that if you will see on your network tab, it means that probably you did something wrong. I wanted to use a different word, you know which one. So how would we define this network time? So this is exactly the time between the server execution finishes and it's pushing the file and before the browser receives file from the server. And as we know, and as probably every small kid knows and even my grandma knows, if the file is small, it will be downloaded fast. If the file is big, it will take a lot to download this. And a lot of us was using torrents back then. And you know very well that if you wanted to download few gigs of a game or a movie or something, it was sometimes taking like a week or so. So we don't want this with our website. We really want to keep our users focused on our website. So these assets that we are shipping should be as small as possible. Of course, there are some factors that we can't have influence on. For example, the network speed. Like, you know, if the network speed of a user is slow, then it's just slow. But again, like if the file is small enough, it would be downloaded even like fast even on the slow network. So ship small assets. Another thing is eliminate dependencies, and this could be a real bottleneck. Like if you see something like this in your waterfall, like usually if you see exactly this is not that much of a problem because this means that we have downloaded index.html, and in the index.html we found some references to other files that we have to download. So you see this on the waterfall. But the problem is when you see a lot of that, because essentially you are making your users wait a lot for the sequence of the request to be made instead of downloading everything at the same time. And like a common example of when something like this could happen is when you're having an import in CSS. And CSS is render blocking, which means that your users won't see anything before it is parsed and downloaded. So imagine that we are downloading this index.html, then we have a reference to a CSS, and in the CSS we are downloading this. We think, oh, there's another reference. So we're downloading this, and then, oh, there's another reference, etc., etc. And we could have downloaded this all in parallel in like 100 milliseconds, or we could wait for one another, and it takes ages. So try to eliminate the dependencies. Also, like in JavaScript files, you can have plenty of them. Another thing is to use HTTP2 and basically, okay, because of the screen you don't see this, but usually like you could see a white bar in here sometimes. And this white bar means that the network request was queued. And there's a lot of reasons why it could happen. But in this particular example, what I wanted to show you is that sometimes if you don't use HTTP2, you have a certain limit on the number of requests that could be downloaded at the same time, so parallelly from a single domain. I think that was 5 or 6. Who knows? Okay, no one knows. So we can even say it was 17. And if you have HTTP2, you don't have this problem. So again, like we would have some kind of a waterfall. So we have to wait for the 5 files, then they're downloaded, then 5 another one, 5 another one. Not very good solution. And most of the servers supports HTTP2 by default, so probably you don't have to bother. But if you will see like this white bars very often, this is probably a place where you have to check. There are some other reasons why the request could be queued as well. Now, this is an important one and commonly overlooked. So when you have a website and when you're downloading things from the same domain, so you have index.html, then all the JavaScript files are also downloaded from the same domain. Actually, the only thing that matters is like time to first byte and then downloading this. But when you have to connect to some external domain before you actually start, like, you know, doing a server work, downloading, etc., a certain procedure has to happen to actually establish a connection between your server and this server. And it could take a lot of time, actually. So imagine that you are having this index.html that is being generated on the server. And to generate it, you also have to call few external domains. And with each of them, you have to establish a new connection and then download this. It will take a lot. So if you want to have a fast website, you should really like minimize the amount of external domains that you're connecting to. And also if you're connecting to them and making like a lot of requests, then it's good to use a keep alive cache header to establish connection that is not gonna be established again and again and again. What else do we have? Yeah, very nice stock image, but the only one I was able to find. So basically use a CDN. What I mean by this? So when you're downloading something from the internet, the physical location, it actually matters a lot. So if the servers are in Berlin, I would download something very fast because probably it will just go through some, a simple wire, like few routers, and here we are. But if the servers are, let's say, in Singapore, it would probably first go to some satellite, then it's gonna be routed to some other country, then from this other country it's gonna be routed like dozens of times before actually the packet arrives. And it takes time, it takes physical time. I mean, it's not that much, but when we are talking about a very long distance, it is very noticeable. So if you use a CDN, you're kind of like ensuring that if the user is requesting something from your website, they're requesting it from the closest physical location. And also coming back to the previous summary, like the fastest code is the one that you don't have to execute. The best request is the one that you don't have to make. So it's also very important to use the cache, like a built-in cache in the browser. So we have like different layers of caching. We have, we could have a cache on the server. We could also have a lot of middle caches, but also we can have a cache in your browser. And this is a very powerful cache because ultimately you can even have, no internet connection and still run the website. So like we should follow this very simple algorithm. When we are downloading something from the internet, then we are putting things that we have downloaded in the local cache in our browser. So the next time we're requesting them, we don't have to wait for them again. We already have those files, right? So we're just taking them from the cache. And if we're navigating to maybe some another route and something is missing, we're just downloading this. But this is a huge save of bandwidth, and at the same time, it is a huge save of time. But of course, there could be a question, but what I should cache? Everything? I don't think so. So there is this pattern called upshell, and what upshell is basically static files. So HTML, JavaScript, CSS, all of this you could it's not changing that much. And even if this is changing, it's probably hashed. So we will validate this. So a common pattern is to put this upshell inside the browser cache. So every time the user is re-entering your website, they immediately see this. It's not a black screen. They immediately have some response. They can hang their eyes on. And in the middle, in the background, we are downloading the content, which could change much more often. And it's also not so easy to version. So this thing, sometimes we can cache, sometimes we can't, or maybe shouldn't because we can't do anything, right? And it's a little bit tougher. But as a rule of thumb, just cache the upshell, cache the static assets, and you will increase the speed a lot. Especially that usually JavaScript files and CSS files and this index HTML, they are very heavy. And you're probably thinking, well, it has to be hard. I've seen some video on the internet about the cache API, and it's terrible. Yes, it is terrible. But don't worry. If there is something terrible, there are usually some high-level tools that are allowing to use it without even knowing how it works. And this is exactly this situation. So Google launched something called Workbox. And Workbox is basically a library that is allowing you to create a service worker with already established cache policies. The service worker is just another thread running in your browser that is acting kind of like a proxy between you and your browser and the server. So when the request is coming, it's coming for service worker, and service worker is deciding, okay, what I should do with this? Should I send it to the browser, or maybe should I put it in the cache? And it's the same thing when you're making a request from the website. So Then it's going through service worker, and service worker is wondering, okay, so do I have it in a cache? Oh, I have it in a cache. So maybe let's take it from the cache and not even hit the network. This way, on your website, you can just have regular requests, and the service worker is actually deciding if they should be served from the cache or not. And Workbox has a Workbox CLI, and you're basically, running it, answering like 5 questions, and everything is ready for you. You don't even have to know how it works. It just works. It's caching your app shell. It's refreshing it. And you can even set up some runtime caching. By runtime caching, I mean content, but it's always risky. And you will see the cached content in your DevTools under Application tab. And it will usually have like this kind of name. Are you following? Everything okay? Good. Okay, so like we know how to optimize the server execution. We know how to optimize the network. That was the easy part. Now let's get into the client. So what we are all good at, right? And the client is basically the browser. And so what we have to optimize here, like what is most important? Well, it's all about JavaScript. Really, like the biggest bottleneck on the client is JavaScript, always. Sometimes images, very rarely CSS. Generally, as a rule of thumb, if you optimize your JavaScript, probably it will be performing right. And it's more about like downloading and executing only the JavaScript that you need, rather than just not having JavaScript. Of course, like if you don't have JavaScript at all, it's a perfect situation, but it's rarely possible, especially these days. So how do we ensure that we are downloading and executing only the JavaScript that we need? Because it costs. Like the time of execution, the time of parsing, for example, for a 2 megabyte image is not equal to the time to parse and execute 2 megabyte JavaScript file. So you should always optimize JavaScript a lot. The size is not only the thing that matters, the execution time is actually the bottleneck here usually. So you should just optimize your critical path. And what is critical path? Well, the easiest definition I could find is basically the code that is needed to display the pixels on the screen. Like if there is anything else, for example, you have to you have a sidebar that is not usually visible, or you have some tracking script, like anything that is not directly responsible for just displaying what your user has to see, is not a critical path and probably can be just downloaded later. The problem is that usually the applications look like this. So we are just downloading like a main.js file or something like this and executing this file. And in this file, we actually have some pieces that are responsible for the critical path, but we also have a lot of some other files that are completely not necessary, required for this action to happen. So ideally, we should like download and execute the critical path code first and lazy load the rest, ideally on demand. And how we could do this? Well, by just utilizing code splitting. Code splitting is, well, as name suggests, splitting your code into different bundles. So instead of having like a one bundle where we have like a main.js file, and in this main.js file we could have a Vue.js itself, maybe Vue router, maybe something else, and some routes, and maybe also some components that are visible only if we click on something. So ideally, we should split all of those and download all of those things only if we need them. So the main.js file is always downloaded. If you're landing on the home page, we are downloading this on home page, and maybe if we click on the card icon, we are downloading card.js. If we click on the newsletter icon, we are downloading newsletter, newsletter submodal.js, etc. And how to do this? Well, like you should just use lazy loading. And like the biggest win, the biggest quick win that if you don't have it yet in your application would probably like, cut your bundle 50%, 60%, 70%, whatever, is just using lazy loading on the routes in your Vue router. So basically right now, anytime we enter any, route, only this route is downloaded. The rest is waiting until we enter that view. And you could do exactly the same with like a bare Vue.js component. So you could imagine that in e-commerce website, we have a cart icon, and if you click on the cart icon, it is invoking downloading the cart component. It's also good to use prefetching. I don't have it here, but if you think a little bit, like this comes with a cost. And the cost is that, okay, we're saving a lot of time at the beginning because we're not downloading this. But if the client user clicks on this on this cart icon, what happens is that have to wait for this to download, so they have a delay. So ideally, download everything that we need for the critical path, and when the browser is on the idle mode, then in the background, download everything else. Now, also another thing that is, to me, a huge problem these days is third-party JavaScript. So like tracking, analytics, and this sort of stuff. You could spend a lot of time on optimizing your website. You could have a beautiful green lighthouse score. Then it goes to production, and the marketing team is putting like 5 tracking codes, also some third-party JavaScript injector, and your score suddenly drops to 7 from 90. I've seen this, really. So it is very common, and like, okay, what we could do with that? Like, they want this code to execute as soon as possible to properly track everything. But at the same time, like, we have a critical path of, let's say, 100 kilobytes of JavaScript and then 700 kilobytes of tracking code. So like all the optimizations are going to hell. Like it feels like they don't matter at all. So there is a thing that was released not that long ago called PartyTown. And what PartyTown is doing, it's actually allowing you to run third-party script in a web worker. What is web worker? This is basically just another thread in the browser, because browser is single-threaded, but you can spawn new threads where the code is executing in parallel. Usually in browsers, the code is executing like from top to bottom. Even if we have asynchronous code, it's not executing asynchronously, it's just delayed. So of course, it's very easy, to block this queue. And if you're spawning a web worker, the critical path, the main thread is still working. Oh, I have a nice image for this. Is still working, but at the same time, in parallel, the worker thread is also running the tracking code. What is a problem with that? The problem with that is that sometimes those tracking codes would require a DOM access, and you don't have that in web worker. There is a project called Worker DOM that is supposed to solve that, but I have no idea if this is already a thing or not. Probably not. And using PartyTown is extremely simple. Basically, when you install a Nux module or Vue.js plugin or whatever, the only thing that you have to do is when you have this third-party script, you're just giving it a label of a text/PartyTown, and it magically works in the web worker. Now, let's talk about a very problematic thing in the front-end applications, which is hydration. Do you know what hydration is? Please raise your hand if you know. Oh, everyone knows. Cool, so I don't have to explain that. But maybe I will, because there are some people watching us that cannot raise their hands. So the process of hydration basically works like this. So when we are having a page that is rendered on the server, we are rendering basically a bare HTML. So like, the code is running, the components are created, the HTML is created, it's being sent to the browser. But what we are getting on the browser is not an interactive application, it's just an HTML. And if there is a lot of JavaScript code, if you click on things, well, they don't do anything. So what is happening is that, this HTML is being parsed. We're discovering that there are some JavaScript files at the bottom, and those JavaScript files are being executed, and Vue.js kicks in and makes this page interactive. And this is a hydrated website. It's like in the Back to the Future, when you were putting this small pizza, and then it was hydrated. So it is exactly like this. No differences. What is the problem? The problem is that, this is our screen, like this thing at the bottom. I hope it's descriptive. So this is the screen, and we don't see everything below. So why the hell would we hydrate this? Like, why the hell would we download this JavaScript, execute it, if we don't need this? And maybe we won't need this, because the user might just click somewhere else. It's a wasted time. So ideally, it should work like this. So we're hydrating only the things that are right now visible and needed, and everything else could be either hydrated on scroll or even on some user interaction because, or maybe not even hydrated at all because it could be just, a text component. Why would you add this whole Vue.js instance into a text component to give all these possibilities while it's not doing anything, right? So we need something better. We need a better solution. And there is something called island architecture. And island architecture is basically all about this. So instead of having a fully hydrated page, you have islands of interactivity. But there is also a very old plugin for Vue 2, actually, very commonly used in Nuxt called Vue Lazy Hydration. I'm pretty sure you don't see that much here because the black text is terrible, but I will try to, tell you what is there. So we are importing Vue Lazy Hydration, which is a component. And we are wrapping our own components into this component and telling through props when actually this, this child component should be hydrated. So here we have when idle. So whenever the browser actually is in idle mode, we are hydrating this because it's probably not very important. We also have never. So when there is a text field, not a text field, but just a bare text, we probably don't have to hydrate it. You can also create a functional component. Here is when visible. This is pretty standard, like we're scrolling. We have to hydrate our components, sometimes on some certain interaction. Sometimes like it could be a click. Sometimes it could be a touch. For the click, I would prefer focus always, because then you're downloading things in advance. So there is like this short time, like 100 milliseconds or something, before user, between user is focusing and clicking, and during this time you can just download the stuff in the background and eliminate the waiting part. And there's also a great framework called Astro. Who knows Astro? Only a few of you. You should definitely check it out because it's amazing. And Astro is designed for the island architecture and it is supporting different frameworks. And Vue is one of them. It is definitely not something that is suitable for enterprise applications, but if you have a simple apps, blogs, this sort of stuff, it's amazing and it's saving a lot of time. If you are building your own personal website and you're building it probably with Nuxt, because we all love Nuxt, you should try Astro. It's better for this sort of stuff. I'm sorry, Daniel. But also I know that in Vue 3, even you is working on actually implementing this sort of features out of the box. So you can correct me if I'm wrong, but there is an algorithm in the making or it is already that is basically detecting if some certain component even has to be hydrated. So it is kind of like, out of the box and granted, right? I'm right. Perfect. Okay, another thing. So I said like it's mostly JavaScript, but sometimes it's not JavaScript. Sometimes it's images. And oh gosh, I've seen so many situations when you have a perfectly optimized website and then you have like 2 megabyte image at the front, or 22 megabyte images, or 1 gigabyte of images. This is basically, like if you do enough scrolling, for example, on a product listing, it's like you're downloading The Witcher. And it's not a rare situation. It happens a lot, really. So images could be the lowest hanging fruit and the biggest bottleneck. And the only thing that you have to do with images is just optimize them lazy load. There is a Nuxt image component, for example, in Nuxt that you can use that kind of like does all of this stuff out of the box and can also be connected with Cloudinary and this sort of things. I know you're starting to move. I'm close to finish. So we have all of this covered, right? We know how to make fast web applications. We don't know the terminology, but we don't give a damn about this terminology because we know where actually all of this is coming from, like what makes our website slow and what influences its performance. And this is cool, right? But how do we actually tell if we optimize our website? Like our boss is coming to us and asking us, okay, can you optimize me a website? And you're saying, of course, I can optimize your website because I've seen the stock. And you're doing this and he's coming back to you and asking you, so how was it? Like, what are the results? And you're saying, I have no idea because I don't know how to measure. So let's fix this. How to measure? Do you know any tool? I'm sure you know, and we all know what you will say, but do you know any tool that is being used to measure performance? Come on, who wants to say this? Yes, Google Lighthouse. Great answer. I wasn't expecting it. So, just accidentally I have this slide. So Google Lighthouse is the most common tool to measure performance. And honestly, I think it's terrible exactly for this particular use case, but not because it's a bad tool. It's because it's being misused in terrible way, because Lighthouse it is running in some particular environment under certain conditions. And when we measure performance, what we have in mind usually is that, okay, so this is how a real users perceive my website. This is a complete lie. Like, for example, if you're running Lighthouse on your own computer, the only thing that you can say is that this website is running good on your computer. Like, that's it. And if people in your company have different computers, and if they will run Lighthouse, you know, the both CPU and network, they are affecting the Lighthouse score. You can apply the throttling to minimize it a little bit, but it's still not a reliable measurement when it comes to like a real world usage. And the sad truth is that Lighthouse itself will never tell you how the real users are experiencing your website. You can use PageSpeed Insights, probably some of you know this. So on PageSpeed Insights, you're actually also running this test on certain conditions. On the mobile, you're running it always on Motorola Moto G4 in the closest data center. So unless all your users are near the closest Google data center or using Motorola G4, it's also not reliable. But when Lighthouse is great if you want to just, you know, check what is the general feeling on the website, if this is slow or fast, and also if you want to measure if there was an improvement. So you launch a version 1, it was a total garbage, as always a version 1, but then you made some improvements, and then you are benchmarking again with Lighthouse, and if you made the benchmark in the same conditions, so the network and CPU are not the factors that made some deltas there, then you can see if there was an improvement. And if I could really like talk an hour why Lighthouse is not the best thing to use to actually measure performance, but I will just leave you with this. You can make a screenshot. I wrote a whole article about this some time ago. Sometimes I'm writing about things that are pissing me off. So if you really want to measure performance, but in a more scientific way, so if you really want, I'm sorry that it's taking so long. If you really want to measure in a scientific way and get more data, actually to profile it properly, use web page test. Web page test is giving you a lot of information. And also at the bottom, you have this nice network tab. And if you highlight on a specific request, you can see what initiated it, like how it is affecting the overall performance. It's amazing. Just use web page test, get tricked by this simple metric. Now, how to take it under control? Because you can measure, you can know what is influencing this, but we know the reality. There are deadlines in the project, and no one cares about performance. That's the truth. So to care about performance, we have to enforce it on ourselves. And how do we enforce it on ourselves? Well, first of all, it would be good to know like where do we want to get. So we should define a performance budget. And performance budget could have a different forms. It could be timing based. So we have some metric that is time related. It could be quantity based. For example, amount of JavaScript files, total image size, or total size of our JavaScript files. It could be also rule based, like this Lighthouse score, for example. And there are two packages that you can use to actually get both. One of them is bundle size. You're just installing this, putting this in your package.json to specify the limit for your files. And you can also put it in your CI, so every time you're making your bundle too big, well, sorry, you can't merge. And there's also a Lighthouse CI, which is doing exactly what you think. It's running Lighthouse on every pull request and giving you this beautiful dashboard, which is telling you if something was improved or not, because this is what Lighthouse is best for. And this is where I am finishing. But before I do this, just one thing. Please remember that performance is always a trade-off. It's not a goal on its own. For example, you could have a score of 100 on a blank website, but you know, like, is it a good business? I don't think so. So you always have to sacrifice maybe analytics script, maybe a feature to get a better performance. And it's not always the best business decision. It doesn't mean that you shouldn't care, because the reality is developers are lazy and majority of websites is poorly optimized, but not because there are so many features and we made the best trade-offs, but because they are just terribly written. Thank you. I hope you had a good time. I hope you learned something. Tell me, like, do you know right now how to make websites fast without this all terminology? One person, at least. Okay, thanks so much.